Okay, good afternoon. So our topic for today, lesson is the derivatives of exponential and logarithmic functions for differential calculus. Okay, our objective for this lesson is discuss and solve problems involving exponential and logarithmic functions by the process of differentiation. So here are some of the formulas that we're going to use for exponential and logarithmic functions. Okay. For some of the functions that are not given here, so I'll be discussing it in our given examples. Okay. So please do not forget our basic derivative formulas because in our examples we'll be going to utilize like basics. Okay. So let's have our first example. Okay, so you're asked to find the derivative of the given function y, which is equal to e raised to x. Okay, so I'm gonna write the function here. So y, which is equal to e raised to 2x. Okay, so for us to determine this is the first derivative. So we're gonna use derivative of e raised to. So this is e raised to u times the derivative of. Okay, so in this case, so y prime, or we can use dy over dx, or we can use y prime. That's just also the same for the first derivative, okay, which is equal to e raised to 2x times the derivative of this 2x, which is equal to 2. Okay, so that's the derivative of the constant and the variable, which is equal to the constant times the derivative of the variable. Okay. So in this case, our answer is 2e raised to 2. So this is the answer for our particular problem. Okay, so do you have any questions with our first example? Okay, so let's proceed. So we're asked to find the derivative of y, which is equal to 3 raised to 4x. So I'm gonna copy the function. So this is y, which is equal to 3 raised to 4x. Remember, so the derivative of a raised to u. So a is a constant, which is equal to a raised to u times ln of a. So getting the first derivative, so that's dy over dx. So which is 3 raised to 4x times ln of the a, which is equal to 2. Or we can rewrite this as 3 raised to 4x ln of 3. Okay. So let's see the answer for this particular item. Okay. So 12 times 3 raised to 4 ln. Of course, we forgot to get the derivative of this 4. So this is times 4. So which is equal to 12 multiplied by 3 raised to 4 ln. Okay. So we can also, if you want to expand this 3 raised to 4x, okay, you do so. But I think it's not quite expandable. So this is your final answer. Okay. Questions? So if you have questions or suggestions, you may comment them in the comment section. Okay, let's proceed. You're asked to find the derivative of y, which is equal to 4x raised to 2x. Okay, so we cannot directly use the exponential differentiation, but we can use the product rule for differentiation. So it's the product rule, that's derivative of u times v. Okay, so this is v du plus u dv. Okay, so I'm gonna write the function again. So this is y, which is equal to 4x e is to 2x. Okay, so we left u, which is equal to 4x. So the derivative of u, which is equal to 4. V, which is equal to e raised to 2x. And the derivative of v, which is equal to 2e 2x. So if you're not sure of why it became 2e raised to 2x, refer to our first example. Okay. So we apply the product rule for differentiation. Okay, so dy over dx. Okay, which is equal to v du, so 4e 2x plus u dv for x times 2, so that's 8x e is equal to x. Okay, so this is the answer for this particular item. Or if you want, you can simplify or factor out the common factor, which is e raised to 2x. That can also be the same. E raised to 2x multiplied by 4 plus 8x. You can also have an answer as this, or use the greatest common factor, which is 2. So we can also say that this is 2e 2x multiplied by 2 plus. However, since 4 and 8 are also factors of 4, we can also say that this is also 4e 4x multiplied by it's 1 plus 2x. So either of the four of the answers will do. Okay, so let's check if our answers are correct. So this is 4 raised to 2x. Okay, questions for our third example. Okay, so let's check. Let's proceed. 4 raised to 2x. So okay, let's proceed with our next example. So we are asked to find the derivative of y, which is equal to ln of sin x. Okay, so the formula is not given. So we're going to write the derivative of ln of u, okay, which is equal to 1 over u times the derivative of u. So we apply that. So I'm going to rewrite the function y, which is equal to ln of sine of x. Okay, which is equal to, okay, so that's in the case. So we get the derivative. So dy over dx. Okay, so that's 1 over sine of x multiplied by the derivative of sine, which is cosine. Okay, or that's equal to cosine x over sine x. Okay, so getting the equivalent trigonometric identity for cosine over sine, so that's equal to cotangent of x. Okay, so this is the answer for our for this item. Okay, questions? Okay, let's proceed. How about this one? So we're asked to find the derivative of y, which is equal to ln of sine x. We already know. So plus ln of a raised to 2x. I'm gonna rewrite the function y, which is equal to ln of sine x plus ln of a raised to 2x. Okay, so we all know the derivative of ln, so I'm gonna rewrite the derivative, dy, which is respect to x. So the derivative of ln of sin x plus cotangent of x. Okay, so based in our previous example, okay, so ln of e raised to 2x, ln and e are two opposite sides, so we cancel this out, so that's 2x. So derivative of 2x, that's positive 2. So this is the answer for our last one. Questions? Well, let's proceed to check our answers. Okay, so for our practice problems, we're asked to find the derivative of the following functions. Okay, so if you need more time, you need to pause the video. Okay, let's check. Okay, so let's answer for number 1. Y, which is equal to x squared a is x. Okay, let's answer this. Okay, so for number 1, so the given function y, which is equal to x squared a raised to x. So this is similar to problem number 2, but it's given x squared. So you're going to use product rule for differentiation. So the derivative of u times b, okay, which is equal to v du plus u dv. Okay, so we let u is equal to x squared, v which is equal to e raised to x. So the derivative of x squared, or the derivative of u, which is equal to 2x, and the derivative of v, of course, e raised to x is also the same as e raised to x. So let's get the dy over dx. So which is v du 2x e raised to x plus u dv x squared dx. Okay, so this is the answer for number 1. Or we can call a factor using the greatest common factor, that's e raised to x multiplied by x squared plus 2x, or 2x plus x squared can be. So this is another form of answer for number 1. Questions for number 1? Number 2. If your given function is y, which is equal to p raised to x cubed ln of x. So we are going to use derivative of a raised to u, which is equal to a raised to u times derivative of u. However, in your exponent, we're going to use another, because we're going to get the derivative of u, we're going to use the product rule for differentiation, which is derivative of ub, okay, which is equal to v du plus u dv. Okay, this is for number 2. Okay. So let's get first the derivative of the exponent. So we left u as x cubed. So the derivative is dx squared. V, which is equal to ln of x. First, the derivative, which is equal to 1 over x. Okay, let's get the dy over dx of the function. Okay, v. So let's copy a raised to x cubed ln of x multiplied v du x squared ln of x. So this is enclosed in parentheses. So this is plus x cubed times 1 over x, or x cubed divided by x, that's x squared. Or this is simply equal to dy over dx, which is equal to, just place this in front. So this is 3x squared ln of x plus x squared, then e is x cubed ln of x. Okay, this is the answer for the 8 questions. Okay, last for number 3. So we'll just write it the solution beneath the number 3 of the third item. Okay, so we're gonna use derivative of a raised to u. Okay, this is a raised to u times ln of a. Of course, don't forget derivative of u. Okay, so let's get the derivative dy over dx. Okay, so this is 3, which is sine 3x, ln of 3 multiplied by 3 cosine 3x. Okay, so this is equal to, so 3 times 3, that's 9. Okay, 9 sine 3x, then cosine 3x, ln of 3. Okay, this is the answer for number 3. Okay, did you get all 3 items correct? Okay, so do you have any questions with our lesson for today? Okay, so if you don't have any questions, we'll see you in our next video lesson. Happy learning.